Hey, I want to talk through homework. This problem was one that I told you not to do. I just want to talk through it to make sure everybody's okay with it. It says identify the sample space using a tree diagram and find all possible outcomes of flipping a dime, picking a card to find its suit, and then flipping a penny. Now, how many cards are there in a deck? But do I need to write out all 52? No, because I know how many are in each one. And then flip a penny. So there are 3 separate things that are going on here. The first thing is I'm flipping a dime, then I'm picking a card, and then I'm flipping a penny. So 2 options for the first one, heads or tails. Off of each of that, then you have options of each of the suits, the spades, diamonds, clubs, hearts. And then the third one would be flip a penny, which means you have heads, tails off each one of these. So what is the first result in the sample space? Head, spades, heads. And how many total would be in the entire sample space? 16. Why? Because 2 times 4 times 2, you're just multiplying how many options there are at each level to figure out how many total would be in the sample space. So I need you to be okay with how to do that. I didn't want you to have to write out all that for homework, though. All right, so actual problems that you did. In a handful of Fruitios cereal, there are 4 blue, 6 orange, 3 red, or 3 green, 2 red, 4 yellow, 5 purple. How many total were there? So you have this written somewhere. Because how did you know that if you didn't write that down? It should have been in the denominator of your answer. So how many of them were purple? 5. But this says not purple, so we're doing the what of it? Complement. So if 5 out of 24 were purple, how many were not purple? And for this homework, I didn't talk about showing work or anything, so I'm just going to go over answers. Starting today, I'm going to talk about how I want you to show your work for everything. 3 says find the probability that it was blue or green. Or mathematically means what? For Friday. Or means what? Plus. So 5 plus 2. Can it be both of those at the same time? Can one be both? No, so I don't have to subtract anything. So it's just 5 or I'm looking at the wrong color. Blue is what? Blue is 4 and green is 3, so it's 7 out of 24. Just to continue on the fact about how, to be completely blunt, how terrible y'all are about going over homework. 3 problems on the test were homework problems, and then 5 of 3 most missed multiple choice questions. So I'm throwing that out there. Given a bag of marbles, 7 are red, numbered 1 to 7, 8 are black, numbered 1 to 8. I'm gonna write this one out showing your work, even though I told you didn't. I'm not gonna think about it for yet. What do I need to know about these 2 things first? About those 2 things. Do they overlap? No. So, or means plus, so it's probability of less than 3 plus probability of greater than 5. How many of those are less than 3? Out of how many? How many of them are greater than 5? Which reduces to red and greater than 6, so they overlap. Yes. So this time I have to do probability of red plus probability of greater than 6 minus ones that are both. So how many of them are red? How many of them are greater than 6?
3.
And how many of the red are greater than 6? Which gives me 9 out of 15, which again is 3/5. Can both of these happen at the same time? Do those overlap? So probability of black plus probability that it's a queen minus probability that a card is black and a queen. How many of them are black?
26 out of 52.
How many of them are queens?
4.
How many of the queens are black? For a total of,
28.
which gives me, going the wrong way, 7 out of 13. Can these overlap? So this one we're just doing probability of 10 plus probability ace. How many 10s are there?
4.
How many aces?
4. 8.
Which gives me
2.
anything with cards get really easy because you're very often using multiples of 4 and 13 when you start realizing that much. Do it for a while. All right, this one there's a jar full of jelly beans. How many total jelly beans are there?
33.
33. So what's the probability that you get a green jelly bean?
8. 7 out of 33.
Not an orange. So how many are orange? 5. So how many of them are not?
3.
It's like a complement problem. Blue or green, so we're adding there. So there's 7 green, 8 blue for a total of, which reduces to
5 over 11.
not a green or blue. So we have that this is green or blue, so not that would just be 6 out of 11. And I'm hoping that these were easy
I got 18.
math-wise.
You. Oh, so yeah, I got it.
That's reduced it. So how many numbers are there? 9. How many of those are odd? 5. How many of them? Which means how many of them are even?
4.
How many of them are a 1-digit number? How many are a 2-digit number?
7.
And how many of them are less than 15? So that part of the homework should have been fairly easy. This was the rest of the worksheet that you didn't have. I just want to talk through it really quick. So this one is saying we've got or, mutually exclusive versus not mutually exclusive. So mutually exclusive, this is more like a refresh. What do we do when we find equation for probability of A or B?
Well, they don't overlap.
Which means probability of A or B equals what? But if they are not mutually exclusive,
Then it's probability of A plus probability of B minus probability of
and then the last one that again was on your worksheet, decide if they're mutually exclusive or not. Number of boys in the math class and number of students involved in athletics. Mutually exclusive or not mutually exclusive? Not mutually exclusive because they could overlap. Number 20, selecting a black card from a standard deck and selecting a heart from a standard deck. Those are mutually exclusive because a heart is what color? Red. So you can't be both a black card and a red card, or a black card and a heart at the same time, so they are mutually exclusive. All right, bookwork. Athletes are often tested for use of performance-enhancing drugs. Drug tests aren't perfect. They sometimes say an athlete took a banned substance when that isn't the case, which is a false positive. Other times, the test concludes that the athlete is clean when he or she actually did take the banned substance. For one commonly used drug, the probability of a false negative is 0.03. What does very, very, very generally from Friday, what do I want you to make sure you have as your answer for A? Talking about what? Where it flattens or evens out, which is where in the process? When in the process?
Already.
Long run. Nothing is short term, just means in the long run, if I did a whole bunch of them, that's where it would level out. I'm going to give you a different written thing to say the exact same thing, but you needed to say in the long run, if a whole bunch of them were done, about 0.03 of them would end up with a false positive. That probably is not applied to every single, we don't interpret it as on the next one, I have a 0.03 chance. Which is more serious in this case, false positive, false negative? That's actually a lead into chapter 7 or 8. I can't remember which one it is off the top of my head. Which one's probably more serious though? False positive because someone who didn't do anything is getting in trouble. Maybe that's worse than somebody getting bad that did do something bad. Really, you could argue either point there. Number 3, suppose a married man and a married woman both carry a gene for cystic fibrosis but don't have the disease themselves. According to the law of genetics, the probability that their first child will develop cystic fibrosis is 0.25. Again, what I want you here doing is, in the long run, if we took a whole bunch of people who were in the exact same scenario, about 25% of them would have their first child develop cystic fibrosis. Why does this probability not say that if the couple has 4 children, one of them is guaranteed to have cystic fibrosis? Because this is what?
Small sample size.
That is a very small sample size, and you are trying to apply a long-run probability to the short term, which you cannot do.
I don't get it. Yeah, this one I was confused on.
So you're saying from Friday that this is where the 0.25 occurs? 0.25. And I'm trying to apply that here. I cannot apply this to the short term. It's because it doesn't have time to level out yet. But that's essentially what I'm saying. You can say it literally just saying you can't apply long-run probability to the short term, but that's the idea of what's going on. Alright, and then again, all of these were really talking about the exact same point. Hello? Hey. Yes. Thank you. Amanda, you gotta go Griffith. So explain what the graph says about chance behavior in the short run versus long run. Well, this one starts way up here, this one starts way up here. We're doing the same problem, same scenario. So why is it okay that one starts way up here and one starts way down here? Because what happens here is what here? And so what happens down here? It becomes more predictable. So what is it not here? It's unpredictable here. So can we directly compare these? No. So even the variation isn't that concerning because it's so unpredictable at that point. All right, so big concepts there are all 3 of those problems talked about probability. Long run is predictable. Short run is unpredictable. You can't apply long run probability to the short term. And what is the one concept that I didn't say by name that all 3 of those apply to? A law. Law of large numbers.